Hello, welcome to the sixth lecture for Mathematics Class 11, Chapter 8, Sequences and Series. So, as we have begun understanding what are sequences, what are the different kind of sequences, and we also saw why we need sequences, and we solved quite a few examples related to sequences, and we also started to understand what is meant by series. So what is series? Series is nothing but the sum of all the terms that make up a sequence. So the as per few of the types of sequences that do exist, we we talked about arithmetic sequences in detail. We saw what are arithmetic sequences, and we also saw what is arithmetic progression. Okay, so even last time we saw that the difference between sequences and progression is that in a sequence you only you can write the list of the terms or objects that have some order or some relation to each other, and progression is when you can represent the entire sequence in the form of a general formula, okay, that gives you the nth term. Okay, so no matter which position of the sequence you're talking about, you can represent that in terms of the nth term formula. Okay, so that is an arithmetic progression. That is a progression. Okay, and we saw arithmetic progression. So we saw the difference, or we saw how we can solve for arithmetic sequences as well as for arithmetic progression. So now we will move on to the next kind of sequences. So these are either we will call them as geometric sequences or geometric progression. Okay, so geometric sequences, as in it's a list of number which have kind of we had a scene in the I think the first class where we establish the relation, okay, when we can have sequences and which are called geometric. So geometric sequences are those where some number is either multiplied to or divided with a single term, okay, which gives you the new term. So anything, suppose you have a1, a2, a3, a4, a5. Okay, so if suppose this is a sequence that you have, so it will be a geometric sequence only if your a2 can be given as a1 is multiplied by some value, okay, or your a2 can be when your a1 is divided by something, so you can say that a1 is also again multiplied by some number, okay, either in like a reciprocal form or any fractional form or as a whole. Okay, so this is when you have for your geometric sequence. Okay, so one example could be, okay, is suppose you have 2, 4, 8, 16, 22. Okay, so over here you have a1 is equal to 2. Now your a2, which is 4, can be your 2 into 2. Okay, so that is your a1 into 2. Then your a3 is 8, which is again, you know that it is going to be equal to a2 into 2. Okay, because 4 into 2 would be 8. So similarly, you can see that your a4 is again going to be a3 into 2, which is your 16. So 8 into 2 is 16. And you have a5. So that is again a4 into 2. So that is 32. So similarly, you can just, write what would be A6. So A6 would be your A5 multiplied by 2. So that is 32 multiplied by 2, and that would be 64. So you can see that the number 2, okay, is being multiplied to each of the preceding terms of the sequence. Okay, so therefore, this is a geometric sequence. Okay, so this is what you can see. So this would be called a geometric sequence. So as we saw in geometric, not geometric, the arithmetic sequence, okay, that you have a common difference, okay, and you can use that to find your nth term. Okay, your n term for your, say, AP was AN equals to A1 plus n minus 1 D. Okay, so you read the first term and the common difference. Okay, so this was for the arithmetic progression. So there has to be some such general, general formula for a geometric progression or a geometric sequence too. Okay, so now we take, let's say, another example. Okay, so that one would be, say, example, we have 1/4, 1/8, 1/16. Okay. Okay. So over here, we suppose we have such kind of a sequence. So what is that constant relation that we have that will help us in finding out what the next next, say, 10 or next 5 numbers are in the sequence. So your A1 is 1/4 and your A2 is 1/8. Now, as we know that A2 would be a product of, say, A1 and something. Okay, so we know that A2 would be A1 multiplied by something. Okay, so let's consider this as actually R. Okay, R. So therefore, this R is going to be equal to A2 by A1. And what would that be then? Your A2 is 1/8 and it is divided by 1/4. So just, multiplied by 4. And you have 1, 2. Your R is 1/2. Okay, so let's check if we get, just by multiplying R to, say, A2, do we get our A3? What do we get as our A3? So A3 would be, say, A2 multiplied by R. So what is our A2? A2 is 1/8 multiplied by 1/2 is equals to 1/16. Okay, so you see that we do get 1/16. So hence this R, okay, so R is equals to 1/2 is the, is crucial for the pattern that is being followed by this geometric sequence. So this R is called the common ratio. Okay, so the common ratio over here is 1/2. Similarly, in the previous example that we had, say, 2, 4, 8, 16, 32. Okay, in this, your A1 is equals to 2, A2 is equals to 4. So if we have to find R, we do A2 by A1, and that would be 2. Okay, and we saw that the number which has to be multiplied to the previous term of the sequence to get the new term of the sequence as 2. Okay, so over here your R is equals to 2, so that is your common ratio is 2. So now we have found the the term or the factor which actually is going to help us in providing the nth term for the uh, geometric progression. Okay, so we will just define our geometric progression now. So geometric progression also can be written as GP. So it is a sequence A1, A2, A3, A4, AN, where each term is non-zero and A k plus 1 upon A k is equals to R, which is a constant for k more than or equal to 1. Okay, so this is how we actually define a geometric progression. Now you can, see that your, suppose your first term is say A. Okay, and now your A2 would be A1 multiplied by something. Okay, A1 into R, so that is AR. Now your A3 would then be A2 multiplied by R. Okay, now A2 is already our AR and multiplied by R. Okay, so then you can write this as AR square. And then you will have you will have A4. So that will be A3 multiplied by R, the constant ratio again. You can just write R is the constant ratio. So this will be now what? AR squared multiplied by R. So this is again AR cubed. So if you kind of write this, it's so on for all the way up to your AN, what you get? AN would be AN minus 1 multiplied by R. Okay, and you can see over here that for A4, your R is raised to N minus 1. Okay, if your N is 4, you can see that R is raised to N minus 1. So what you get is finally as A, that is your, the first term multiplied by R raised to N minus 1. Okay, so this actually then becomes your AN equals to AR N minus 1. So where your A is your first term and R is your common ratio. Okay, so this is how you can get the nth term for any geometric progression. Okay, so let's just take an a small example to find your AN for that matter. Okay, how we can find. Suppose you have say 1 upon 9, 1 upon 7, 1 upon 1 equal to 43. Okay, suppose this is your sequence. So let's find our R first. Okay, so R would be say A2 by A1. So our A2 is 1 by 27 and divided by 1 by 9. So this is 9. So this is 3 is 1 by 3. Okay, this we have got. Suppose now we want to see what is the fifth term. Okay, so fifth term. So if you can, just see the relation that we were seeing, where your A2 is, AR and A3 is AR square. So over here, your A2, even if you write your A 1 by 9 multiplied by your R, okay, so this will be 3. So this becomes 1 upon 27. Okay, your A3 should be then AR squared. So your AR is 9. So 9, 3 squared. Okay, 1 upon 3 squared. So your 3 squared would be 9 itself. So 1 upon 9 multiplied by 1 upon 9 would be what? It would be 1 upon 81. So which is our A3. Okay, so if you want to find the fifth term, so obviously you can just multiply your R, okay, over here. So you will have A5 as A4 into R. So A4 is 1 upon 243 multiplied by 1 by 3. So this is your 1 upon 9 to 1, 729. Or if you just use your AN formula is A into R n minus 1, right? This is our formula that we had got for nth term. So that will A is 1 upon 9, okay, multiplied by your R raised to n minus 1. So we are finding the fifth term. So this will be 1 upon 3 raised to 4. Okay, so that is 1 upon 9 multiplied by 1 upon 81. Okay, so that in itself will give you 9 and 729. Okay, so now we have, let's find, say, something where we don't have a previous term. Okay, so suppose we want to find A12. So then in terms of A12, what we would have is your A R raised to n minus 1. So this would be 11. So that is 1 upon 9 multiplied by 1 upon 3 raised to 11. Okay, so your 3 raised to 11 would be, this actually then gives you 95. Yeah, so this would be actually a very large number. So, okay, so this is how you can, find any nth term for your geometric progression. Okay, so some terminologies, if we, explain it right away, is your for geometric progression. Okay, your A is first term, R is the common ratio, L is the last term, N is the number of terms, and if you have the Sn, so that is the sum of first n terms. Okay, so this is what we have. Now, one thing that you have to remember is that geometric progression too, just like in terms of arithmetic progression. So your GP can be finite or infinite. Okay, so finite is where you have A1, A2, or just write it in the GP form. Okay, so where you have AR, AR squared, AR cube, all the way up to AR n minus 1. Okay, so this is finite, but for infinite, even you take ar squared, ar cubed, ar, say even if you have n minus 1, it can go beyond that too. Okay, so that is your infinite geometric progression. Okay, let's quickly then summarize all the formula that we have, okay, for geometric progression. So for your geometric progression, let's say, so your sequence would be ar, ar square, ar n minus 1. Okay, the common ratio can be given as r, which is equals to say ar n minus 1 upon ar n minus 2. Okay, or your a n minus 1. Oh, sorry. Yeah, or this would be an minus 1. Okay, so either way you can get it if you already, obviously to get your common ratio with r would be difficult. We first have to find r. Okay, so this is your, you can use both these formula, and then your general term. So your an is going to be ar n minus 1. Okay, and if we now take the series, okay, so your series, there is obviously we have say, for arithmetic progression we could have an arithmetic series where it would be the sum of all the terms. Okay, so you can also have a geometric series, so that is the sum of first n terms of the GP. Okay, so we will go into the series, later on. We will see all the different, that is kind of series that are there. Let's do some examples, okay, to understand the concept of geometric progression. So suppose you have 0.01, 0.0001, okay, and so on. So whenever we are given a series, okay, so what we will first try to see is whether it's a geometric series, okay, or it is an arithmetic progression, okay, arithmetic series or your arithmetic progression. So first what we will do, let's cross check whether it's, we know that this is geometric progression. Okay, because we're solving it under the geometric progression. So let's just first go off and find the common ratio R. Okay, so that would be common ratio R. So that is your an by an minus 1. So suppose you take a2. So a2 is 0.0001 and divided by 0.01. Okay, so that is, then you will get it as 0.01 as your R. Okay, so that would mean that any term, we can find it using this common term. So your A3 is should be your A2 multiplied by R. So our A2 is 0.001, okay, multiplied by 0.01, which is a common ratio, and you do get it as 0.23451. Okay, so you can see that it is, giving you the same answer that we have. So suppose let's see if we have to find, okay, say the fifth term. Okay, suppose you want to find the fifth term. Okay, so, or actually, let's just take the A6. Okay, A6. So that would be, using our general term formula, your A and A6 would be A multiplied by R raised to n minus 1. So that is R raised to 5. Okay. So what you will get is your A is 0.01, and this you will get as actually 1 multiplied by 10 raised to minus 10. Okay. So in the terms as suppose you have, R is equals to 0.01, you can write it as 1 into 10 raised to minus 2. So if you take R5, so that is 1 into 10 raised to minus 2 raised to 5, you will get this as 1 into 10 raised to minus 10. Okay, so in that way, you will have 1 into 10 raised to minus 2 multiplied by 1 into 10 raised to minus 10. Okay, so this you will actually get it as 1 into, so now you add because you are multiplying the, 10 to with respect to some power. This you get as minus 12, your A6. Okay, so you can see that it is easier when we have, this A into R raised to 5. So no matter what the previous term is, all you require is your first term and your common ratio. Okay, so this is easy. Then, so let's do some more examples. Okay, question. Okay, so suppose this is your sequence. What is R? And write the general term for your nth term. Okay, and suppose you want to find A raised to A8. Okay, so let's find R. So R, as you know, is an upon an minus 1. So you have, say, A2 upon A1. So what do we get is half multiplied by minus 1. So this is minus half. So let's just cross check if that is what, we get even with the different one. So suppose you take A3 by A2. So A3 is 1 by 4. And this will be multiplied by 2. Yeah. So our common ratio, okay, R is equals to minus 1 by 2. So now our AN, okay, any general, any nth term would be A R n minus 1. So that is, what is our A? A is minus 1. Okay, and R is 1 minus half. Okay, n minus 1. Now your sign of this formula would depend on your n. Okay, so suppose now you want to find A8. Just excuse me, I'll have some water. again. So A8, A r raised to 7. So our A is -1, and this r is your -1 by 2, 7. Okay, now as you know, the power over here, okay, is an odd number, so your negative sign will remain even for the r. Okay, so minus half, -1 by 2 raised to 7. So we'll just write it as 2 raised to 7 is going to give you 128. So now negative negative, you can multiply, it becomes positive. So your answer is 1 upon 128. Okay. So similarly, if suppose you had to find some, larger term. Okay. So suppose we want to find what is A20 or say A21. Okay. So let's see what would we will get. A25. Okay. We want to find A25. Okay, so now with respect to r, this is our a r raised to 24. Okay, so our r raised to 24 would be -1 and -1 by 2 raised to 24. Okay, so now where your minus sign will go as and when we solve for 1 by 2 raised to 24, and you will get the term as a negative. So 1 upon, so this is a large number again, so you have 1, 6, 7, 7, 7, 2, 1, 6. Okay, so it is easy now when you can, find it in these terms. Let's take another example then. Okay, so your question is, we have 3, 6, 4, 48. Okay, so it's the same. Let's find R first, then we'll find A N, and we will find, say, A7 for this. So our R would be A2 by A1. So that is 6 by 3, it's 2. Okay. And so therefore our AN would be A raised to n minus 1. So that is A is 3. 3 into our R is 2, n minus 1. So now if we have to find our A7, okay, so A7 will have 3 multiplied by 2, so 7 minus 1, 6. Okay, so 2 raised to 6 will give you 3 into 8 into 8 into 64. Okay, and then this will give you 192. Suppose you are also asked to find your A12. Okay, so A12 would then have your 3 into 2 raised to 12 minus 1, 11. Okay, 3, your 2 raised to 11 is 2048. So then this will become 4, 15, 6, 1, 4, 4. Okay, easy. So it's you can find it out. Let's take another example now. Okay, so you will have, say, 1, 3, 9, 27, 81. Okay, so your first is it AP or GP? Okay, so let's see if there are, your AP or GP, then 2 find formula for a n. Okay. So suppose, if for an AP, your A2 minus A1 should be your B. So 3 minus 1 is 2. Okay. And whether the same common difference is being followed for the next set of, between the next number and the previous number, we will take A3 minus A2. So A3 minus A2 is your 9 minus 3. So that is 6. So these two are, not equal. Therefore, not an arithmetic progression. Okay, so for GP, we have to find if we have a common ratio. Okay, so for that you will have A2 by A1. Okay, so 3 by 1 is 3. And then you have A3 by A2. So that is 9 by 3. So that is also 3. Okay, so we have a common ratio. Common ratio R is equals to 3. Okay, therefore it is a GP. Okay, so it is a geometric progression. Now we want to find what is the uh, geometric sequence. Okay, so your geometric sequence would then be your A n is A r raised to n minus 1. Okay, so that would be your A is 1. Okay, and your this is 3 raised to n minus 1. Okay, so now 1 will be, it will remain. So finally, what you can write an as 3n minus 1. Okay, so we can understand that, this GP is nothing but all it's the, sequence of or a set of all the powers of 3. Okay, so this is what we get. An is equals to 3 n minus raised to 3, raised to n minus 1. Okay, so this is your general formula. So even if you have to find, say your A8, so all you have to find is 3 raised to n minus 1. Okay, so now over here your n is 8. So you have to find 3 raised to 7. A8 would be 3 raised to 7, and that is 2187. Okay, so it is easy. Obviously, you will have more, complicated series, in later on where you will have, either difficult kind of, say, difficult ratios, okay, or you might not get, proper, the relation between the terms will not be so straightforward. Okay. And obviously, when you are asked in a statement form, you will have to convert it into a geometric progression. So let's do another, just one last, say, example. Okay. So question is you have 1 minus 3 9 minus 27. Okay. So suppose this is what we have. Now let us first find your R. So find R A N. So you have for R, we will have A2 by A1. So minus 3 by 1 is minus 3. And for say A3 by A2, if we get the same thing, so that is 9 by minus 3. Yeah, so that is minus 3. So your AN then becomes your A, that is your first term. Okay. Okay, so that will be ARN minus 1. So this is your 1 multiplied by minus 3 and minus 1. So this you can see is, similar to the previous one, okay, where your AN is equals to 3 raised to minus 1. Now this is minus 3 raised to n minus 1. Okay. So the sign of your term is going to depend on your n. So suppose if we have, say, we have been doing 4, right? 4 terms here. So if we have A5, so that is going to be minus 3 raised to 4. Okay. So if because it's raised to 4, you will have a positive term. So that is going to be 81. Okay. Suppose we have a raised to, sorry, A8. Okay. So this will then become minus 3 raised to 7. Now, as you can see that the power over here is odd. Okay. So your negative sign is going to remain over here. So with the negative sign remaining over here, this will be minus 2187. Okay, so this is how you can solve for geometric progressions. So today we mostly did only we tried to understand the geometric progression, how you can find the common ratio, and how we can generate the formula for the geometric progression in terms of the nth term. Okay, so that is why no matter what kind of a sequence is given to us, now with respect to whether arithmetic progression or geometric progression, we can find the formula for the nth term for both. Okay, so for arithmetic sequence, you need the common difference for solving the arithmetic progressions, and for geometric progressions, we need a common ratio between two consecutive terms of the sequences. Okay, and obviously the terms, the terms also, the nth term also is different. I'll just quickly give you the differences between AP and GP. Okay, so suppose you have AP here and you have GP here. Okay, and we find the differences. Okay, so the first difference is we have a common difference B, which is equals to A2 minus A1 or AN minus AN minus 1. And for GP, we have a common ratio. Okay, so common ratio is R is equals to, say, A2 by A1, or it is AN by AN minus 1. Okay, and the nth term is given as A. Suppose your first term is A1 is equals to A. Okay, so your first term plus, let's just write your AN here. The nth term AN is equals to A plus N minus 1B. Okay, so with respect to your GP, if your A1 is equals to A, your AN, okay, so your nth term AN will be given as AR, so that is a common ratio raised to N minus 1. Okay, so these are the basic differences between arithmetic progression and geometric progression. We will also see when we have understood, or we have seen how to solve for the geometric progressions series. Okay, so we will also add the differences between the series formula of AP and GP. Okay, so we will stop here for today. So thank you for attending the class.